Suppose a robot has a straight arm 18 inches long that can rotate about the origin in a coordinate plane. If the robot's hand is located at 18, 0, and then rotates through an angle of 60 degrees, what is the new location of the hand? Let's sketch a coordinate plane. The robot's hand initially is at 18, 0. That's the location on the x-axis, 18 units to the right of the origin. The robot's hand then rotates through an angle of 60 degrees, so it rotates up this way to a point through an angle of 60 degrees. This point then will follow through the end of the arm, or where the hand is, follow through and come to a new point here. Now, from the diagram, we can learn a couple of things. First, there's a circular path that this arm follows through. The radius here of 18 units will stay the same. That's the length of the robot's arm. So this 18 travels from here to here, and which is also the distance from the origin to the new point. Now, we have a right triangle that we could form if we drop a perpendicular down to the x-axis. What we know about that right triangle is that the hypotenuse is 18. We don't know the x-coordinate. We don't know the y-coordinate, or the vertical and horizontal distances, which I'll label x and y. We do know that the angle is 60 degrees. If we place the angle here as is indicated, then x is the adjacent side and y is the opposite side of the right triangle, and we can use the properties that the cosine of theta should equal the adjacent side over the hypotenuse, and that the sine of theta should equal the opposite side over the hypotenuse. So let's fill in what we know. The cosine of theta is the cosine of 60 degrees, and the cosine of 60 degrees we know to be 1/2. So the cosine of 60 is 1/2, and that equals the adjacent side, which we don't know, but we've labeled x, divided by the hypotenuse of 18. Multiplying both sides by 18 gives me 9 for the x-coordinate of the robot's hand. Similarly, the sine of theta is the square root of 3 over 2. That's the sine of 60 degrees. And that should equal the opposite side, which is not known, divided by 18, which is the hypotenuse. Once again, if we cross-multiply to solve, or simply multiply both sides by 18, we obtain 18 times the square root of 3 over 2 gives us 9 square root of 3 for our y value. So that gives me the x and y coordinate for the robot's hand location. That will be the point 9, 9 square root of 3.